trig equations. So first, we're going to look at finding solutions in an interval. So first, when we are looking for the solutions, we're going to be using the unit circle. And we do have to pay attention to the interval to see if it's 0 or 2 pi, because those are the same spot on the unit circle, right? So notice here in my instructions, it says very clearly that the interval includes 0 and does not include 2 pi. Right? That's what that parenthesis is. So if our answer was at that point on the unit circle, we would say 0 there. So when we solve a trig equation, we act just like it's a normal equation. And remember, what we're trying to find here is theta, right? So I've got to get that cosine theta all by itself. So the first thing I would do here is what? Add 1 to both sides, right? So then I would have 3 cosine theta is what, 0? Correct? And then I would divide both sides by 3. So the cosine of theta is 0. So now we've got to think about the unit circle and where the cosine of theta is 0. So the cosine of theta is 0 where x is 0, right? And x is 0 at what? Where's my x value 0 on the unit circle? Up top, right, at pi over 2. And at the bottom at 3 pi over 2. So those are your solutions, pi over 2 and 3 pi over 2. 2 cosine theta plus 1 equals 0. So we would subtract 1, and we would have 2 cosine theta is negative 1. And then I would divide both sides by 2. Cosine theta is negative 1/2. So now we're going to go to the unit circle. Cosine is negative where x is negative, right? On that left-hand side. And so that's quadrant 2 and quadrant 3, right? My cosine is 1/2 for my family of over 3's. So now we say, what is my over 3 in quadrant 2? That's 2 pi over 3. And my over 3 in quadrant 3 is 4 pi over 3. So we're just isolating that trig and then going to the unit circle. The sine of theta minus 4. So we're going to add 4 to both sides. And I get the sine of theta is 1. So the sine of theta is 1 where y is 1, correct? Because sine is y. And there's only one place on the unit circle where the y value is a positive 1, and that is pi over 2. So now we're going to do the same thing, except our instructions are going to change just a little bit. So here, my instructions are going to say find all solutions to the equation. Those last instructions said to find the solution in the interval, okay? So when we're finding all solutions, we do the same thing we just did, except we add 2k pi, where k is in z, to each solution. So what does that mean? Plus 2k pi, where k is an integer, z is the math symbol for integers, right? So if k was 1, that would add 2 pi, right? If k is 2, that would add 2 pi, etc. So what it's doing is adding rotations. So when it wants all solutions, you add that little bit. And very kindly in Alex, there's a button that has all of that in it, okay? So you don't have to remember what all of that is. Now, the little caveat here is if the solutions are pi apart, instead of doing 2k pi, we just do k pi, where k is in z. And again, there's a button with that on it in Alex, okay? And it'll make a little bit more sense when we get to one that has that situation. So we're going to do the same thing we did a minute ago. To solve this first equation, we're going to add 4 root 3 to both sides, right? So I'm going to have 8 cosine theta equals 4 root 3. So next I would divide by 8, right? And we'll have cosine theta equals 4 root 3 over 8, which reduces to root 3 over 2. Cool so far? All right, so now we've got to go to the unit circle, and cosine is positive in quadrant 1 and quadrant 4, right, on that right-hand side. And the cosine, or the x value, is root 3 for my family of over 6s. My over 6 in quadrant 1 is pi over 6. And my over 6 in quadrant 4 is 11 pi over 6, right? So now I'm going to look at those two and be sure they are not a distance of pi apart. Well, pi is 6 pi over 6, correct? So if I subtract those two, I do not get 6 pi over 6, right? So they are not pi apart. So that means both of these just get a plus 2 k pi, where k is in z. K pi, where k is in z. And so these are our two solutions. Let's look at cosine theta equals 0. Well, cosine theta equals 0 where x is 0, right? And we did this one just a minute ago. And so theta is pi over 2, right? That x is 0 at pi over 2. And x is 0 at 3 pi over 2, right? But pi over 2 and 3 pi over 2 are a distance of pi apart, correct? If I subtract them, I get 2 pi over 2, which is pi. So since they are pi apart, I only need the first one, and I add k pi, where k is in z. Because as soon as k is 1, I'm picking up the 3 pi over 2, right? So this just has one answer, and it's that one. Looking at the next one, we are going to do the same thing. I'm going to subtract root 2 from both sides. So I have 2 cosine theta equals negative root 2. And then I'm going to divide both sides by 2. So cosine theta is negative root 2 over 2. Then I'm going to go to the unit circle, and cosine is negative on the left-hand side, right, in quadrant 2 and quadrant 3. And my cosine value is root 2 over 2 for my family of over 4s. So my over 4 in quadrant 2 is 3 pi over 4. And my over 4 in quadrant 3 is 5 pi over 4. Are these two pi apart? No, right? Because pi apart would be 3 pi over 4 and 7 pi over 4, right? So both of these need the 2k pi where k is in z. Plus 2k pi where k is in z. So those are our answers. Everybody okay? So those only use sine and cosine. Next, we're going to do the same thing, but we're finding solutions in the interval. So notice this says interval, so that means we don't need the 2k pi, right? It says all solutions, we do need the 2k pi. So doing the exact same thing, we're going to add root 2 to both sides. And so we have secant theta is root 2. And that means that the cosine of theta must be 1 over root 2, correct? So then I would rationalize that, and I get that the cosine of theta is root 2 over 2. Cosine is positive in quadrant 1 and quadrant 4 on that right-hand side. And my x-coordinate is root 2 over 2 for my family of over 4s. So my theta in my over 4 in quadrant 1 is pi over 4. And my over 4 in quadrant 4 is 7 pi over 4. You okay? All right, tangent theta, we are going to subtract 1 from both sides, so we get tangent theta is negative 1. Okay, so tangent is negative where the signs are opposite, right? So tangent is negative in quadrant 2 and quadrant 4. And my tangent is 1 where my x and y's are the same, right? And so that's my family of over 4s. So my over 4 in quadrant 2 is 3 pi over 4. And my over 4 in quadrant 4 is 7 pi over 4. Okay? Getting it?
So we put those in as the solution.
Yes, these are your solutions. Here I have a cosecant. So we would say that cosecant theta is negative 1, which means that the sine of theta is negative 1. And the sine of theta is negative 1 in only one place at 3 pi over 2, right? And now we're going to do the same thing with more than sine and cosine, finding all solutions. So the only difference between this and what we just did is the 2k pi, or the k pi, depending. So we have secant theta minus 2, so we will add 2 to both sides. So secant theta is 2. That means that the cosine of theta must be 1/2. Cosine is positive on the right-hand side, right? So that's quadrant 1 and quadrant 4. And the x-coordinate is 1/2 for my family of over 3s. So in quadrant 1, my over 3 is pi over 3. In quadrant 4, my over 3 is 5 pi over 3. Are they pi apart? Well, pi would be 3 pi over 3, right? So if I added 3 pi over 3 to pi over 3, that would be 4 pi over 3, right? So they're more than pi apart, so they each need the 2k pi. Plus 2k pi, where k is in z. All right, now we have a cosecant. So we're going to add 2 to both sides. I'll have root 3 cosecant theta equals 2. And then I'm dividing by root 3. So the cosecant of theta is 2 over root 3, which means the sine of theta is root 3 over 2. Sine is positive on the top, right, where y is positive at quadrant 1 and quadrant 2. And my y is root 3 over 2 for my family of over 3s. So my over 3 in quadrant 1 is pi over 3. And my over 3 in quadrant 2 is 2 pi over 3. And they are not pi apart, correct? So they both get the 2k pi, where k is in z. Plus 2k pi, where k is in z. One more. Now we have a cotangent. So we're going to add 1 to both sides, and I'm going to have root 3 cotangent theta equals 1. So the cotangent of theta is 1 over root 3. So cotangent is positive where the signs are the same, right? The x and y have the same sign, and so that is in quadrant 1 and quadrant 3. If cotangent is 1 over root 3, that's x over y, right? So that means my ordered pair must be a 1/2 root 3 over 2. There's my x over y, and that is my family of over 3s. So my over 3 in quadrant 1 is pi over 3. And my over 3 in quadrant 3 is 4 pi over 3. Are those pi apart? Yeah, they are. If I subtract them, I get 3 pi over 3, which is pi. Or you can think about adding pi, which is 3 pi over 3 to the first guy, right? And we get 4 pi over 3. So that means for the top guy, we'll do plus k pi, where k is in z. Because as soon as we hit k is 1, then we're picking up that 4 pi over 3. So this is the only answer you need.